Hi there, so today we're just going to work on some old exam questions because they're pretty good, and it has a kind of a variety of different ways to ask questions, and then a couple ones that are always on the exam. So I'm on page 10 right now, just where the old exam questions start, and this is one from a little while ago. It was the first question on the exam, and let's take a look at what this says here. So, which equation does the graph represent? And it gives me a bunch of equations that are all pretty similar and then a beautiful picture. Now, one way to go about this is guess and check. And guessing and checking, not bad at all, where you just enter this into your graphing calculator and see which one matches this the best. Before I guess and check, I'd like to narrow this down just a little bit so I don't have to check all of them, because that would take quite a bit of time, and I don't like taking quite a bit of time to do stuff. So let's narrow this down by the easiest thing I can think of, which is the y-intercept. The y-intercept is the constant. So it's either -3 or +3. Looking at my graph, I think the y-intercept's right about here, and that's definitely a positive number. So I'm guessing it's going to be a 3. It's definitely not down in the negative. So I'm going to cross off the ones that have -3s. So now I'm just down to these two right here, and if you have taken some of these graphing topics before, you can probably see which one it is right now, but if you haven't, easy way to go about this is just to guess and check, and let's see what happens. So let's practice that, just because it is good practice to graph stuff in your calculator. Let's go to y equals. I'm going to erase the stuff I had in there before, type this guy in. Reminder, when we have a leading coefficient, we have to use that weird negative at the bottom. 2x squared plus 7x plus 3. I graphed it just with the windows that I had, which don't really make a ton of sense right now, so I'm just going to change my window settings a bit. I'm going to go to my just go-to window settings, which is -10 to 10. It usually works out pretty good for me. So those are my go-to window settings. Hit graph, and there's my graph. Does this match that? No, it doesn't. So I'm going to say B is not it. I could certainly double check C, but I'm thinking it's going to be C. One way you could see that happening without actually graphing it is that this had a negative, which makes it an unhappy quadratic. So it would have looked like this, which is what we found. This one has a positive leading coefficient, which makes it a happy quadratic, which looks like that. Now, for our purposes, I don't need you to know that. I need you to be able to find that using your calculator or by any other means, but it's good background information. Sometimes you'll get a cubic, and I'm not expecting you to know what a negative leading coefficient cubic looks compared to a positive. So I just need you to have tools in your tool belt to figure this out. Now, this is a really good question, and I definitely want you to try it, but I want to leave that one for you to try on your own. So I'd like to try number 6 together, because it's a similar type of question where it has one of these graphs that we're going to have to do. So I'd like you to go back to that other one in a moment when we're done trying these ones. So this is question 6 in the old exam. It's worth 6 marks in total, and there's an A, B, and a C and a D going on here. Now the biggest thing with these questions, especially when there's an A, B, C, D part, the number one thing I want you to remember is that you know how to do at least parts of this. So sometimes you're like, oh my gosh, I know that's not right. A is the first part. I don't know how to do that. Try to come up with something and keep working with it, because you could get a wrong answer in A, but you could do the graphing part right because you're great at graphing. And then you're going to get an answer for C and D based on A, but if you do those parts correctly, based on what you got with A, you can still get full marks for C and D. So let's say you have no idea how to come up with an regression equation, you're just blanking because it's a stressful time. Still continue on and do everything that you can. Maybe leave it for a little later, come back to it, but still try everything you can on it, so that way you're not losing 6 marks because the first question looked really hard. Okay, so that's my number one suggestion for your exam and for tests in general, is try to put something down and keep going. That's all. All right, so Bailey launched his remote control plane. He recorded the height of the plane at different times during the flight. Here we have a table of stuff, determine the cubic regression. Now they're giving us a hint right here, and they might not always give us a hint. So sometimes we have to try a few different things, but they're telling me it's a cubic, which means it should be x cubed somewhere. And they're looking for the regression equation, which is like the line of best fit. So hopefully this is old hat by now, but if you need the reminder, this is what we're going to try and do. Probably just get out of this stuff. Don't need any of this other stuff in there anymore. I need to tell my calculator this information. So start that by going stat 1 or enter for edit. Clear all this other junk I have in here. And let's put in our table. Now this is especially important that we don't make any mistakes when we're typing this in. And I'm the worst for saying that and then accidentally just doing it because I have a hard time saying exactly what I'm doing. So here we go. I have it typed in. I'm just going to give it a quick double check over and make sure I didn't make any mistakes. And now I think I can find the cubic regression equation. So to do that, we're going to go back to stat. This time I want to calculate something, so over calc. I need a cubic, so I'm going to pick 6 for cubic. Might have to hit enter a couple times. And here's my whole cubic equation. So what I type in, what I put in this spot is this right here. A is 1.48 x cubed minus 9.79 x squared plus 17.12 x plus 0.56. Oh, that's pretty long, but that's okay. Beauty. Create a clearly labeled graph. So I don't need this equation. Ooh, I don't need this equation right now, but I'm not going to clear it because if I need to graph and find stuff off of this, I need to have this still on my screen. So I'm just going to put this off to the side, but I'm not going to hit clear. And I'm going to work on this for a few minutes and then we'll come back to that. Create a clearly labeled graph. All right, we need axis titles. So what is each axis? We need axis scales, we need dots, and we need probably a line through here as well. So typically, whenever we have time, that's going to be on the bottom. So I'm going to throw time on the bottom. And it's in seconds, so we just put that in brackets. On the side, we have height. And that's in feet, so put that in brackets as well. It's really nice when they give you a table because it tells you how big things should be. So time should go from 0 to 5. And usually they'll give you kind of a grid, but this time they didn't, so it's fine. I'm going to try and go up to like 6, I think. Just so that way, if I want to see a little bit further, I can. So I'm going to try and space these as evenly as I can without using a ruler, just because I'm a little too lazy for that. So I'm going to say 6 is over here, and then I'm just going to try and split it up as evenly as I can, knowing that usually they're going to give me a grid. And then in terms of the y direction, we're going from 0 to 26. So I'm going to try and go from 0 to 30, because I think that's a little bit easier to do. I'm going to try and split this up as evenly as I can. I think I'm just going to go up by 5s. Now, reminder, the most important thing with a scale is number 1, we pick something reasonable. The dogs are playing in the background here. We pick something reasonable, like 0 to 6 is going to fit all of our data points. We want that to happen. And then we need to go up by an appropriate amount every time, and we be consistent. So I said 1 tick is 1. So we're going up by 1s every time here. So 1 tick is always 1. On this side, we're going up 1 tick is 5. So every time I'm going up by 5s. If I'm not consistent, I won't get the marks for it. Lastly, we're going to put some points on here. So time 0, height 0. Boom. Nice. Time 1, 9. Now it's not going to be perfect. I'm not going to use a ruler and try and like measure it out or anything like that. I'm just doing my best to put it in the general right area. 2 is 7. 3 is 3. 4 is 7 again. And 5 is 26. So it's not perfect, but it's good enough. Now here's a question for you. Should we connect the dots with a line? Now it doesn't specifically ask me to, but I want to take a look at the situation and decide that. What we're deciding is the data continuous or is it discrete? Could we reasonably put a point right here and say, what's a time at 4.5 seconds? Well, this is a remote control plane flying. So at any moment in time, you should be able to tell what the height is, right? Like if you videotaped it, you should be able to pause it at any moment and see. So yeah, it would be reasonable to put a dot right at 4.5. It'd be reasonable to put a dot at 3.1 seconds if I knew what that was exactly. So that's a reasonable thing to say. We could put a line through here, but since it doesn't ask me to, maybe I won't. But we certainly could, and then we could put arrows in maybe one direction. What direction could I put that in? Can I put an arrow going towards -0 time? Maybe not. I mean negative time, not -0, just negative time. Because negative time doesn't make sense as a real thing, right? But we were probably flying this for longer than 5 seconds, so I could totally put an arrow going off to the right. All right, now there's more questions on the back here. Using your equation part A, determine how long it will take the plane to reach a height of 100. So even if you made a mistake, excuse me, in part A, we could still potentially get the mark for part C, because when I mark it, I would have to type in your equation and try it. Oh, my calculator just turned off. Okay. Now for me to be able to use this, I have to graph it. So I'm going to want to copy and paste this into my y equals. Let's go y equals. Delete the stuff I had in there before. Copy and paste it by going vars 5 over to EQ. You can see why I have this memorized because I do it so often. I'm going to hit graph, but I'm probably going to have to adjust my window settings a bit. Oh, that's what it looks like apparently. Now I can adjust my window settings kind of based on the graph that we just made, but I also want to make sure I have the question in here. So how long will it take for the plane to reach a height of 100? So I'm thinking height, that's this way, that's the y-axis way. I need that to at least say 100. So let's go to our window. That y max, let's make it like 110, just so we can see. And I'll probably have to change my scale. Let's change it to 10, so we count up by tens. So you can see those little scale points that are counting up by tens. Beautiful. And I think I can see the point at 100 there. So that's great. I don't think I have to adjust my x-axis unless I want to. Now height is 100. That's a y value. That's the more annoying way. So let's go y equals, don't clear that, hit 100. Wait for it to cross. We're looking for that intersection point. So second trace, 5 for intersection. Just hit enter 3 times. Give it a moment and it thinks about it and then it tells me, okay, when y is 100, x is 6.44. So 6.44, make sure we have a unit. I think it's seconds is what we're talking about here, and we're done. I know I'm going pretty fast because I've done this so many times at this point, and hopefully so have you when you're practicing. But if you want to look back at how we do some of these things, take a look at the first or second video, or the third video even, and take a look at how we do them. Now here's the last question. This is the one I really wanted to make sure we got to, so this is why we did this question. One limitation of the domain. So my graph kind of looked like this, kind of like that. So the graph that we graphed looked like. And they only gave me quadrant 1. They didn't give me quadrant 2 as well. Like they didn't extend this x-axis this way. And I think they did that for a reason. So one limitation is saying, what's one place that we would have unreasonable values? And we're specifically talking about the domain, so we're not talking about the range, going the y value, we're just talking about the x value. Now, I think they didn't give me the second quadrant because that would have been negative time. And it's unreasonable to say, what are we doing at negative time? Because chances are you're flying this remote control car, you may be videotaping it. You start when you start. You can't start before you have started and start graphing that, right? That's unrealistic. So one limitation is to say, you can't have negative time. And we're just saying that the graph itself, like when I graph this, in my graph, it shows me, if I adjust my window settings, it will show me all the negative x values, all the negative y values, because it doesn't know what situation we're talking about. It only knows the regression equation, which is not the same as the situation that we're talking about. So one limitation of the domain is saying we can't have negative time. Another one might be we can't have infinity time either. We're going to have to stop flying this thing at some point. If we're talking about limitations of the range, it might be we might not be able to have negative y values because you know, going down to the negative, you'd be going into a hole, and we wouldn't be able to have positive infinity y values because at some point, you know, you'd reach how high up a remote control plane can go, and at some point it just can't go up that high because it can't escape our atmosphere. It just can't go up that high. So there's at some point you can't go any higher. So there'll be some limitations of the range. Now there's a couple other old exam questions in here. Please give those a shot and see how they go. Otherwise, have a good night.